6QRC introduces a layer of mathematics that no one's ever seen, and it requires a metaphor strong enough to make something that's invisible visible. That's why the eagle is here. Even 1,000 feet in the sky, an eagle can look down at a distant river and see a small fish, and maybe even its heartbeat. 6QRC is eagle vision for the classroom. Through the eyes of 6QRC, students and teachers can finally see elements of a math problem that are otherwise invisible with today's methods and tools. Through the light of 6QRC, three powerful things become visible. Number one, I want to tell you something I've seen with my own eyes. Year after year, I watched the same scene repeat. The teacher introduced a new problem. The room went silent. No one answered. And the teacher walked to the board and wrote the formula down and went through the formula to reach the answer, step by step. Students nodded along and copied, saying they understood. But I have watched what happens after class, when the professor is gone. Students sit together and say, "What was she talking about? Let's put our heads together." That is a reasoning transfer failure happening in real time, because what never took root in the lesson was structural vision. The expert read the problem and its structure lit up instantly. They saw it right away. But the expert's first act of visual intake was unspoken and undisplayed to the students. This is what we call a vantage point hurdle. It's when problem perception becomes so sharp, the expert can no longer see what it looks like to a novice. So they teach from the point where their own perception exists. The student is not standing in that place. The student sees unstructured surface text. The expert sees a structured task. These are two different cognitive worlds. And here is the deeper issue. Every major framework begins from the expert's vantage point, not the novice's. Polya assumes the solver understands the situation well enough to make a plan. Schema theory describes how experts recognize problem types. Cognitive load theory reduces the burden of solving, but it doesn't explain how a novice gains access to the site that pulls the problem together. Each framework starts from the vantage point of an expert. None of them reach back far enough to where perception begins. This is the blind spot, and this is exactly what 6QRC was built for. Number two. Number three, the pre-solve structure. Before a student touches a single calculation, 6QRC gives them something that's never existed as a designed object in math instruction. It gives them a structured output generated before solving begins. We call it the bird's eye view before dropping into the trees. It lets them identify exactly what they are entering. It gives the student the actions to find out what's present in the problem, what's missing, and what sequence of reasoning actions the task requires. That output has never been built into a system before this one. Students have always been sent into the trees without ever seeing the terrain. What I've shown you today is not the horizon of this system. It's only the shoreline. The deeper waters belong to the experts who step in.